Wow. How are we going to get that LLM?
I'm sure we can get the open source model on Hugging Face.
Really? Is that wise? I mean, I thought open source models from Hugging Face were inherently risky, like a self-executing package or something.
Many cybersecurity professionals mistakenly believe that downloading models from Hugging Face carries similar risks to downloading and running executable packages or Docker containers. But the reality is that LLM models are fundamentally data structures that require explicit loading and execution through specific frameworks. They cannot self-execute or run arbitrary code without being deliberately loaded through libraries like PyTorch or TensorFlow. You see, LLMs, or large language models, have revolutionized the way we interact with technology, enabling advanced natural language processing capabilities. From customer service chatbots to code generation tools, LLMs are transforming industries by automating and enhancing tasks.
Yes!
However, with great power comes great responsibility. Now, you're not wrong to be concerned. The rise of LLMs also introduces new security challenges, such as ensuring data integrity, mitigating adversarial inputs, and protecting against misuse. To understand how to protect systems leveraging LLMs, we must first identify the primary risks. These include prompt injection attacks, where threat actors manipulate input prompts to exploit model behavior. Training data poisoning, where malicious data inserted into training datasets compromises the model's outputs. Data leakage, where sensitive information is inadvertently exposed in responses or during training processes. And model exploitation, where abusing the predictive power of LLMs is used to generate harmful content or to perform malicious tasks.
That sounds pretty risky to me.
Each of these risks presents a unique challenge requiring tailored mitigation strategies. Comprehending these vectors is the first step toward building a secure AI ecosystem. So, building a secure foundation for AI systems involves adopting proactive measures and industry best practices. Here's some key strategies for you to consider. Data governance. Ensure data used for training and fine-tuning is vetted, anonymized, and compliant with regulations. Access control. Restrict access to LLM APIs and systems to authorized personnel only. Continuous monitoring. Regularly audit model outputs and system logs to detect anomalies or misuse. Community collaboration. Engage with AI security forums and initiatives to stay updated on emerging threats and solutions. By laying these foundational pillars, our organization can better withstand the challenges of AI security while unlocking the full potential of LLM-driven innovation.
Yeah, but is it really worth it?
It's crucial to establish a clear distinction between large language models, LLMs, and self-executing containers, such as Docker. An LLM is essentially a computational model trained to understand and generate human-like text. However, it does not possess the ability to run autonomously. It must be actively loaded and executed through application code written by developers. In contrast, Docker containers are prepackaged units containing software, code, and dependencies. They can be configured to automatically launch processes as soon as they start running. This makes them highly versatile, but also introduces security risks specific to their functionality. For example, Docker containers could face threats like container escape, where a malicious actor gains access to the host system, or vulnerabilities due to exposed network ports. When it comes to LLM models, the primary risk vectors, essentially the ways security could be compromised, stem from unsafe serialization formats. Serialization is a process of converting objects into a format that can be stored or transferred. Formats like Pickle, a popular Python serialization library, can deserialize arbitrary code, creating opportunities for attackers to execute malicious payloads if the model isn't securely handled.
This is a lot to take in. How can I apply this information?
Okay, well, let's delve into a striking real-world example to better understand these risks. In February of 2024, JFrog Security Research uncovered a malicious PyTorch model uploaded to the Hugging Face platform by a user with the pseudonym Baller423. Hugging Face, for those unfamiliar, is a popular repository for sharing AI models. This particular model contained a payload hidden within a pickle file, a type of file used for Python object serialization. When the pickle file was loaded onto a victim's machine, it granted the attacker what is known as a reverse shell. A reverse shell essentially allows an adversary to establish remote access to a device, enabling them to execute commands and extract sensitive data, all unbeknownst to the user. This incident underscores the critical need for safer serialization formats, such as safe tensors, which are specifically designed to prevent arbitrary code execution. Safe tensors ensure that serialization data cannot be exploited for malicious purposes, making them a robust alternative to Pickle in terms of security.
Wow.
To protect against these risks, cybersecurity professionals should adopt comprehensive best practices for secure LLM usage. Let's break these down. Model validation. Always verify the integrity of a model before using it, ensuring there are no tampered components or malicious code embedded. Platform security features. Take advantage of security tools provided by platforms like Hugging Face or TensorFlow, which can help mitigate risks. Safe loading practices. Use serialization formats like safe tensors and avoid unsafe alternatives to minimize vulnerability to attacks. Monitoring and incident response. Regularly monitor model activity for unusual behavior and establish protocols to address incidents swiftly. Input/output validation. Carefully validate all data being input into and output from the model to prevent injection attacks, a technique where attackers exploit input fields to execute harmful commands. Organizational policies. Develop and enforce policies that govern the secure handling and deployment of LLMs within your organization. Each of these measures contributes to a robust defensive strategy against evolving threats in the AI landscape.
Oh, okay. Well, now this makes sense. I can see why you're so confident.
So, as you can see, it is vital to focus on specific risk vectors when working with LLMs, such as serialization formats and prompt injection attacks. Prompt injection attacks refer to manipulating the instructions a model receives to produce unintended results. These risks demand targeted security controls rather than an overarching fear of open source models.
Got it. Thank you so much. I'm starting to feel a lot better about this.
Remember, LLMs are not inherently dangerous executable code. They are tools that require thoughtful implementation. By applying appropriate safeguards, you can harness their potential securely and effectively.
Right. Remember the safeguards: model validation, platform security features, safe loading practices, monitoring and incident response, input/output validation, and organizational policies.
That's it. You got it. And explore further educational resources such as the OWASP GenAI Security Project, which provides valuable insights into AI security, and Hugging Face documentation, which offers detailed guidance on using AI models safely. Stay informed, stay secure, and continue advancing your knowledge in this exciting field.